And we're back. Let's see. Yeah, so as I was saying, we're going along the z-axis, and first we took this point 0, 0, 25, and 25 happens to be the optimum value of the constraint optimization problem. We draw a plane parallel to the xy plane or perpendicular to the z-axis, and this plane over here happens to intersect the parabola tangentially at this point here, x5, y0, z25. And then we take a point that's a little above 25, there is 25, so x0, y0, z50 for example, and we again draw a plane perpendicular to the z-axis and it intersects the parabola at point 1 and point 2. Now, as I explained before, if we want to find del f at point 1 or point 2, all we need to do is go along this direction, and this is our del f. Similarly, we'll call this point 3, the one below, which is happens to also be the optimal point, x5, y0, z25, and del f at point 3 is simply an extension of the perpendicular line from the z-axis to this plane. So this is del f3. Del f1 was at point 1 and del f2 is at point 2. And now what about del c? As I mentioned before, del c is always parallel to the x-axis. So it will always be pointing outward and parallel to the x-axis. So at point 1, del c1 will be like this. At point 2, del c1 will also be parallel to the x-axis, and at point 3, del c1 will actually be del c3 will be parallel to del f3. Now, what does that mean? So if you look at points 1 and 2, what we see is that moving along anywhere along this plane means we are moving perpendicular to del c, because this whole plane is perpendicular to del c, the x equal to 5 plane. So if we move from point 1 along the parabola, so let's do that here, from point 1 downwards along the parabola, we are moving perpendicular to del c1 but not perpendicular to del f1, because del f1 is not perpendicular to this plane. And in general, if we move in a general direction along this plane, we are not necessarily perpendicular to del f1. In fact, what happens at point 1 is that del f1 dot, if we call this direction d, which is, let's say, along the tangent to the parabola, let's call it d1, then del f1 dot d1 happens to be less than 0. Similarly, at point 2, let's call the direction along the parabola d2. We again see that del f2 dot d2 is less than 0, while at the same time del c1 dot d1 is equal to 0, because del c1 is perpendicular to the entire plane, and del c2 dot d2 is also equal to 0. So at points 1 and 2, if you move along d1 and d2, which are directions along the parabola, the blue parabola, you end up decreasing f, because the dot product with del f is less than 0, while at the same time not changing c at all, because the dot product with the gradient of c at both these points for both these directions d1 and d2 is equal to 0. So you are able to decrease f without violating your constraint, which is awesome, because that's what we ever wanted to do, remember? Decrease f as far as we can while being constrained by this c function. So we can keep doing that until we get to this point 3. And at point 3, something special happens. Now del f and del c align. And what that means is that in order to decrease del f further, I mean, it's technically possible to decrease it further. It's f is 25 here, but at the origin here, all the way down there, it's actually 0. So it's possible to go from this point where it's 25 to the origin where it's 0, hence decreasing it further. But if you go towards the origin, you are no longer perpendicular to del c. And in fact, the dot product with del c is less than 0. So if we call this direction that's going from this point 3 towards the origin d3, then d3 dot del c3 is actually less than 0 and not equal to 0. So you end up violating the constraint. And that's the reason that point 3 is as low as we can make f. You can't make it any lower than 25. If you want to make it any lower, you're moving in a direction that is not perpendicular to del c, and hence you're violating the constraint. So that's the intuition for why Lagrange multipliers work and why we want del f to be a linear scale of del c. We want these two vectors to be parallel. Thanks for watching.